Hello, hello, hoi. Welcome to the Dutch and Frisian Common Voice Contribute-a-thon. My name's Abby. I'll be your MC for today. I lead Mozilla's developer-focused strategy around trustworthy AI and the Mozilla Festival. And speaking of MozFest, it's coming up. Early bird tickets are available. MozFest is a unique hybrid that brings together artists, technologists, activists, and more in this diverse global movement fighting for a more humane digital world. So Amsterdam will be MozFest's home for the next 3 years. So that's why we've partnered with 2 Dutch institutions, the Amsterdam University of Applied Sciences, or the HAVIA, and the University of Groningen Campus Friesland, to build community in the Netherlands while working towards better speech recognition technology for Dutch and Frisian speakers using Common Voice. So we'll be hearing more about Common Voice from some of our speakers today, but it is one of Mozilla's initiatives to help teach machines how real people speak. It's an open source database that anyone can donate to or use. So this brings us to our challenge. Over the next week, we are challenging any Dutch and Frisian speakers to use Common Voice to record and validate as many hours of your language as possible. So by donating your voice, we'll have better data to create more innovative speech technologies for your community. So the voice data that we collect this week will actually be bringing that to MozFest, to our Trustworthy AI Hackathon, where we'll invite our community to build better voice tech using your data. So it's a really good reason to donate this week. So stay tuned at the end of the call. We'll give you instructions on how to contribute and how to claim prizes. But today we do have the pleasure of hearing from some excellent speakers, Josh Meyer and Nanda Piersma. So we do want to make this conversation as interactive as possible. So if you get any questions during the event, please use the hashtag #CVChallenge on Twitter, and we'll be making sure our speakers get that. So first up, I do want to introduce Josh Meyer. Dr. Meyer is the lead scientist for speech technology at ARTI Incorporated and an advisor to Mozilla's speech technology efforts in Africa. His expertise is in automatic speech recognition, speech synthesis, and natural language processing. Josh is an advocate of democratizing speech technology for all the world's languages. And personally, Josh has been a huge help with bringing more of our AI community around MozFest and Mozilla generally. So with that, Josh, please take it away.
Thank you so much for the introduction, Abby, and I'm really excited to be here. And I will just jump in and start sharing slides. Okay, can we see okay? Oh, I'm ahead of it. Okay. So as Abby said, I've been involved with some of Mozilla's speech tech efforts. And today, what I really want to talk about is speech technologies and the role of community activation and how important that really is in making speech technologies. So my name is Josh. I am a 2020 machine learning fellow at Mozilla and also, as Abby said, the lead scientist for speech technologies at ARTI Inc. And I've been working for a long time with lots of different language technologies, and in particular with language technologies for so-called underserved languages. Basically languages that aren't getting as much support from data sets, from technologies, from especially open technologies and data sets as they could be. Today, what I want to talk about is Common Voice, the Common Voice project, what it is, why it's important, especially why it's important right now, and how it's relevant to the Dutch situation with Frisian and Dutch and the different varieties therein, where data and Common Voice plays a part in the speech machine learning pipeline, and community activation, and really how community activation is the starting point for getting the ball rolling on these technologies. Without community activation, we're not going to get language technologies for most of the world's languages. So that's where we need to start. And also what's next, how you as an individual can start contributing. It's easy. So first, what is Common Voice? If you've seen the Common Voice web app, you might think it's a really slick user interface. Some people think of it as kind of game or language learning, but at the core, what is Common Voice? It's a project and a set of technologies built around speech data. It's a set of technologies for collecting, validating, and distributing these data. Because at the end of the day, the collection and validation are what we might think of as the kind of the fun parts. But the distribution is what this is all going towards, distributing for researchers and engineers so that they can use the data to create useful technologies. While speech data is the core, it is not possible without community. It's a community-based project and a community-driven project. What that means is the communities for each language start, they gather the data, they make it possible to start collecting more data. I'll get into that a little bit more in a second. But it's driven by the community. So it's not that Mozilla, the foundation or the corporation, are pushing for different languages. It's really the languages that succeed with Common Voice are the languages that activate themselves and push to gather more data. So Common Voice is a project that started about 3.5 years ago. It started just with English, but since then it has grown just exponentially. Almost 10,000 hours of audio have been collected, audio as in speech, as in people talking. Started with English, and now already over 60 languages are collecting data right now on the web app, and over 60 more languages are in the pipeline getting ready to launch so that they can start collecting data. There's a whole host of different developers who have made this technology possible. The core project is open source. It's hosted on GitHub. If you are a web developer and you want to help out, you can go to github.com/Mozilla and look around for a few different repos related to Common Voice. But the Common Voice repo is the most popular. It's easy to get started. And of course, the actual people who are recording audio, who are making contributions, they are the ones who are making the data, and there's tons of them. This number is actually out of date. It's in the hundreds of thousands. And so these indicators show us how Common Voice has grown and how it can grow for new languages, especially Dutch and Frisian. So very concretely, what does it look like when you go to donate your voice? That's maybe a phrase you haven't heard before. It sounds a little strange. What it is you're presented with a sentence and you hit the record button, you read the sentence, you hit the stop button, and that's it. What you've done, what's going on behind that is you have created a pair of audio and transcript so that we can use that data later for training machine learning models. But it's as simple as that. You don't have to worry about file formats or anything. It's just reading, and you can read as many as you want. After you have read the audio, because it's possible to make mistakes with reading, it happens all the time. You might have hit the microphone too early, you might have hit the stop too late. To make sure that that is not a problem that's making the quality of the data degrade, there's these quality assurance checks, which we call validating. So what happens, you've recorded audio, you've already sent it up to the Mozilla platform. Now other people who log in can go listen to your audio, see the sentence that you were supposed to read, and make sure that it actually matches up. And this way we can vote. Is it correct? Is it incorrect? And we can kind of get out the mistakes before they get distributed to the community of researchers and engineers. So this is, in kind of a historical side note, this is a really smart way to get around this transcription problem, because what's happened previously is to create these data sets, researchers and engineers will record tons and tons of audio, and then they'll transcribe it after the fact. But that transcription can take 10 hours, up to 10 hours of transcription time for 1 hour of audio. It's really labor intensive. This way, it's effortless. It takes some volunteer time, but it's an easy process, and you can just keep scaling to new languages without having to worry about transcription problems. So I've talked about how you record audio, how you validate audio. At the end of the day, people want to use this data. And the process for downloading the data set is just as easy as donating. You go to the website, the same commonvoice.mozilla.org, download the data set, and you can do whatever you want. You can do research, you can publish, you can make commercial products, as long as you make sure you've got enough disk space. Some of these files can be lots of gigs. Adding new languages is also easy. On the same Common Voice web app, you can go to the languages section, check if your language is there. If it's not, there's instructions for how to get started. So why is Common Voice so important, and why is it important right now? I think this can be summed up in one slide, which is the future is here. It's just not evenly distributed. If you're an English speaker and in an English-speaking country, you run into language technologies every day. I don't remember the last time that I called my bank and I talked to a human right away. For as long as I can remember, I've called and I talked to a machine, a voice bot. And sometimes I don't ever actually talk to a human during that process because the voice bot understands my credit card number, it understands my address, it understands what I want. All of these things save time and money. They create value for businesses. They create value for humans. There are other technologies based on speech that are really a necessity for people with disabilities, people who have vision impairments. And these technologies already exist, but they only exist for a few languages. And the problem with that, where that problem comes from is the few languages have been seen as kind of commercially viable. So there's over 7,000 languages in the world, depending on how you count them. To get that kind of technology to the rest of the languages, it's going to take community effort. So I've told you about what the project is, how it collects data, how you download data, why it's important. I want to show you just really quick where this data fits into the entire speech machine learning pipeline. So if I talk about a minimum viable voice assistant, like this bank voice bot that I just mentioned, you can see there's a few steps to go from me talking, the machine understanding what I said, the machine making a decision and responding back to me. There's multiple steps here. Common Voice is all about collecting data for the first step, going from speech to text. And this is, in a lot of ways, the most crucial step because the cost of collecting data for this is just exponentially more expensive than any of the other steps. The other steps, if you're a developer and you're really motivated, you might be able to go collect enough data by yourself. For speech to text, there is no way that one person is going to collect enough data for an application that will work for a wider audience. It's just impossible. You need a small army of volunteers to make this possible, and that's what Common Voice does. Traditionally, and why is Common Voice kind of different than other corpora? Like I said, other corpora, like corpora is a speech data set, a speech corpora. Traditionally, what people have done, these are projects from academic institutions, they were, until Common Voice came around, the benchmark data sets. These were the data sets everybody knew about and recorded, but these all are expensive. They were all recorded in academic environments, and they don't scale well. So Common Voice is special not just for engineering and making the applications possible, but for research and making research open. So community activation, what does that really mean? When I talk about community activation, I'm talking about focused efforts where there is a core community who is making, collecting text data, collecting the voice data, promoting, organizing events, basically what exactly is happening this week for the Dutch and Frisian languages. That is community activation. And what I think is really important is understanding that while it might to some people seem like a small group of people who are kind of up against this huge challenge, collecting tons and tons of audio data, you think, okay, we're a small community, we're not going to be able to get the same kind of technology as English because we just don't have enough people, we don't have enough data, we can't do it. And I want to say that that thankfully is not true. You might think, for instance, the big languages have more data. This is for Common Voice, how many hours of data some of the bigger languages have: English, German, French, Spanish. Each of these languages has hundreds of millions of speakers. English might have in the billions if we talk about second language learners. And so you think, okay, English did it because they have a massive community. However, these are not the top 4 languages for Common Voice. They're in the top 7. And these other languages, you might not be familiar with. And you might be surprised that these languages have managed to collect so much data. Kinyarwanda is a Bantu language spoken in Rwanda and other countries. It's got maybe tens of millions of speakers, but not more than that. Catalan, minority language spoken in Spain, and they've got a considerable amount more. They have considerably more data than Spanish. And Kabyle is a Berber language spoken in Northern Africa. These languages managed to collect enough data to make viable products because of community activation. Diving a little deeper into why Kinyarwanda versus English, because Kinyarwanda is just a perfect example of what a concentrated community effort can accomplish. They found that there's this community of volunteers that they can just tap into. There's a strong tradition of doing volunteer work. And in the last year, they have collected almost as much data as English, and English has been collecting data for 3.5 years. So when we're talking about these large amounts of data, in a very short time, you can get something that's really, really usable. So how do you get started? Go to commonvoice.mozilla.org. It's really easy. You can sign up for a profile so that you can kind of keep track of how much you're donating, how much progress you've made. But just go to the website. It's very intuitive. Start donating as soon as you can. It's as simple as that. And for anybody who wants to use the data, this is really the icing on the cake for people who want to use the data. It's licensed under a Creative Commons 0 license. It's public domain. You can do whatever you want with the data. You can do research, you can publish findings, you can change the data set, redistribute it. You can make commercial products on top of the data with no worries, no cost, no nothing. It's public domain, it's yours, it's your data. It's been collected by the community for the community. And at that, I want to say thank you for listening. I really look forward to questions, and thank you for your time.
Thank you so much, Josh. And that was really inspiring, especially that Kinyarwanda example, just how that language has just skyrocketed. If anyone watching has any questions for Josh, please use the CV challenge hashtag, and we'll actually do questions for both of our speakers at the end. But just, yeah, so I do want to move us on to our next speaker, Nanda Piersma. And we are so honored to have you here today, Nanda. Just to introduce her, Nanda Piersma is a professor of responsible IT, affiliated with the Amsterdam University of Applied Sciences and the National Research Institute for Mathematics and Computer Science. Her professorship investigates how parties in the city can gain better insights into data through data analysis, algorithms, and business analytics. Since January 2020, she is the science director of the Havia Expertise Center Applied Artificial Intelligence. Nanda is a popular speaker and regularly gives presentations to government institutions and business networks. She's involved in several data science networks, including Amsterdam Data Science and the Big Data Alliance. So we're so thrilled to have you here today, Nanda. I'll let you take it away.
Well, thank you. I hope everybody can hear me. And you didn't see me because I immediately put in my slides. I'm sorry for that. I'll stop sharing at the end so I can wave to everyone. Yes, as said, at the University of Applied Science in Amsterdam, also called Hogeschool van Amsterdam in Dutch, we started with artificial intelligence initiatives by creating an expertise center that is aiming at all our 50,000 students. So it's a bit of a big undertaking. And we now have 7 labs, and these labs are within each of the faculties of our school. And
we don't see your full screen of the slides. We're seeing
the other one. Okay.
A view, yeah.
See if I can change that. This one?
No, we still see the other view. It's fine. You can continue with this. We can still see.
I'm sorry.
Okay.
I started sharing the wrong one. I probably did. So I'm sorry. So I will talk today about a small project that we did with our students within the Responsible AI Lab, which is aiming at media and creative industry, where we had a very high ambition that we wanted to do a sentiment analysis of audio. And we thought we now have enough pre-trained algorithms that can find the sentiment in an audio clipping to see if there's something going wrong. And well, I have a picture of the Senate in the United States where you can see, are these peaceful protesters or is something going wrong? Can we detect these situations by studying an audio clipping? The second thing that we wanted to do is see, can we get the sentiment of an interview that is performed, or a job interview for that, so that you can use artificial intelligence to help you to find the right candidate. If we were doing that, so we had a sentiment analysis of speech, we saw it as an extension of the algorithms that already exist for sentiment and analysis in text. And I saw that Josh also had a setup where we say, okay, we have a clipping, sound clipping, we move it into text, and then we analyze the text. If you do that with artificial intelligence, and the artificial intelligence basically is a model of what people can do when they do it by hand. So if we listen to an audio text, we may be able to determine whether the audio clipping is positive, negative, or neutral. The same as we can do for visual recognition. And what we want to do with these models is to find what the error is for what the algorithm is doing compared to what we can do as humans. So let's do a deep dive, just a small deep dive. I'm not going to give you too much details, but if you have a neural network, what you do is you feed an algorithm with inputs, and you say, okay, look at these inputs and determine whether this is a positive or a negative or a neutral sentiment.
Nanda?
Yeah?
We still see slide number 2.
I'm sorry.
Is that...
I will stop sharing and then do it again.
Here we are. No, we see the correct one now. Continue.
Okay.
I think this is good. Okay.
So this is setup of an AI training algorithm. So what we do with an AI training algorithm, you have a set that you use for training. And for this set of sound clips, you determine what is the correct output. Is this positive? Is this negative? And then you train an algorithm to understand this and to do this for a new data. So you have a new test set where you give the algorithm the input, but you do not give the algorithm the output. And you compare what you know is the correct output with what the algorithm says should be the output. And to give you an example of that, is it going on the next slide? Probably.
Yes, yes.
Okay, so give you an example. Here we have faces, and I have now, you see 7 people with faces, and we, with our human mind, said, okay, there is output. The people in the top row have a neutral face, the people in the second row are smiling, the third are angry, and the fourth row is screaming. Now, can we give some input factors that we can use to estimate for a new person if he's neutral, smiling, angry, or screaming? So we say input factor should be the way the mouth and the eyes are looking. So if you have your mouth shut and your eyes wide open, it's neutral. If you have your mouth open, your eyes open, you're smiling. If you have your mouth shut and your eyes open, you're angry. And if you have your mouth closed and your eyes closed, then you're screaming. Or your mouth open, I'm sorry. So we say this is the input layer on the right. And we annotated for all these people, all these 7 persons. We annotated, usually you need more, but we annotated that this is the way what the sentiment is. And then we get a new person in. So now we have a new person in. And we asked the algorithm, the woman in the top row, what's her expression? And they says, okay, you gave us eyes shut, mouth open, mouth shut, eyes open. This is an angry person. And the second one is smiling. The third one is angry. The fourth one is screaming. So this is the test set. And we compare what the algorithm says to what it is actually. And we see there is 1 error and 3 are correct. And this is the way that we compare algorithms to the reality. And the setup of an AI training therefore is you train the algorithm, giving it the input and the correct output. Then the algorithm sets up itself, and then you test it on a new test set, another test set, and you give the algorithm only the input, and you calculate the error. Now, let's go to speech. What we wanted is to have the artificial intelligence algorithms that already exist there, that were pre-trained. They're also already trained to find the sentiment in an audio clip. And we got this from the Google surroundings, and our students said, okay, we just tested first on an English test sound clips. So we have a test set with English sound clips that we got. I actually saw the library. We got it on a license from research institutes, and we just retrained, or we didn't train it, but we just tested the pre-trained neural network on these sound clips, and it was correct in 95% of the cases. And then we said, now we need a Dutch test set, and let's see how well it's doing. But we didn't have a Dutch test set, so the students produced their own test set by speaking into a lot of different sound clips. And I think we should add them to your website now. But then when we tested the pre-trained algorithm, it was doing very poorly. In 3 out of 4 cases, it gave us the wrong sentiment. So we said, this is not the right way to work with this if you use Dutch language. So let's do another one. Let's just do a pre-trained sound-to-text algorithm where we have an English training sound clips into an English training text. And that's the way that Jos was setting it up. And then use a pre-trained neural network, and you see 96% gives you the correct sentiment. So what we wanted to do, can we reproduce this using these pre-trained algorithms on Dutch sound clips into Dutch text, into Dutch test set? Well, it stopped right at the first one. Well, we didn't have time enough, as Josh already said himself, to get the Dutch test sound clips into Dutch training text. So we abandoned this one. We said, no, we're not going to do this one. So then we came up with the technical solution to all this. If you look at the sound clip, if you listen to the sound clip, it has technical factors on it, so such as frequency, amplitude, timbre. So we just used the 7 factors of sound, and we said, if it's English or Dutch, it shouldn't make any difference. They all have the same 7 characteristics, 7 factors, and maybe we can use that. And there's also a pre-trained algorithm to find the sentiment in a sound clip using these technical factors. So the English sound factor training set that we found and the pre-trained neural network worked correctly in 95% of the cases. So then we said, the only thing we have to do is to have our Dutch sound clips, extract the factors from that, and then use the pre-trained algorithm. So we have the Dutch sound clips, and we changed that into factors. We feeded the Dutch sound factors test set into the pre-trained algorithm, and we're still not happy. It's 54% of the cases that it was correct. It's better than the other ones, but still we're missing out on something. So now we were wondering, and that's where we need our partners for now at the Rijksuniversiteit Groningen, what are we missing? Well, of course, we know that languages differ. And maybe it's the tone of voice of each language that differs, but we feel that the main issue that we have to solve here is that the annotation, finding if a sound clip is positive, negative, or neutral, so the sentiment analysis, it's not neutral. And I have a few pictures that we can look at. Are the women on the left top, are they happy, or are they smiling, or are they suppressed? The men in the middle, do they have a discussion, a debate, or an argument? Are these Black Lives Matter protesters, are they empowering? Is a positive sentiment, or are they protesting? Is it a negative sentiment? In each of the pictures, if you do the annotation, there is a cultural bagage that you bring with it. And the same holds for sound clips. And it goes even further. If you have the moral compass, there is a Nature article with a survey of 2.3 million people who were asked, what if we have a self-driving car, and the self-driving car has the dilemma, it has to see, it is going to crash, and you will need to tell the car what to do. Should it spare humans? Should it spare pedestrians? Should it spare females? And if you look at the picture, you see that there's a major difference between Western people, Eastern people, and Southern people in who do you want to spare. So Southern people want to spare people with a higher status, whereas Western people prefer to be inactive. And you see all these differences. And that's something that we need to take into account with the annotation of our sentiment analysis. So where are we? I think what we need to do is start training our own algorithms. So if we have the Dutch and Frisian training for sound clips that we are now try together and that we can easily download, we can train our own neural networks. And we can find our own test sound clips. Or we can do it, as Jos said, to the sound text training process and then the neural network on the training text set. Either one of these, I want to tell you a little bit in a deep dive of how we are performing with these algorithms. Please help us with these spoken audio clips, and that we are not depending on English text because it just doesn't work on Dutch and Frisian. Thank you very much, and I will stop sharing my screen, hopefully.
Thank you so much, Nanda. That was an excellent presentation. And you do have a couple questions if you have time before you go.
Just a quick question, yes.
Okay,
thanks.
we'll do one question, and then maybe we'll ask you to answer the rest of them asynchronously. So first question, is the photo analysis comparable to an ontological analysis of words, sentences, and total story?
It's of the same complexity we found. So photo analysis has visual markings in faces, for instance, or visual markings in objects. And it's a different ballgame, but I used it to explain what artificial intelligence algorithms are doing. And I didn't fully discover the ontology analysis of words, all the different aspects that we can use. So we've started with just a very quick and dirty and a sort of lazy way to look at audio clippings with, and I think lazy is in trying to get pre-trained algorithms. We're not getting away with pre-trained algorithms. We're not getting away with sound clips that are collected by research institutes, as Jos already said. So I think this common initiative is really good and really helpful. And for us, it's now trying to find more complex algorithms using all the richness of these audio clippings.
Thank you so much, Nanda. So I know you have to jump,
Yes,
but it was such a pleasure having you here. So thank you
very much.
And for everyone else who's watching, we do still have Josh here, so we can go back to the Q&A for his section. If you have any questions, please use the CV challenge hashtag, and we'll be sure to get to them. And if you had questions for Nanda, we'll email her those questions and make sure we get those responses back to you on Twitter or in the YouTube comments. So question for Josh. How many speakers are needed for the Common Voice data for this to be actual usable data?
That is a great question. Let me get a couple slides, I think, that are relevant to that. Okay, can you see? Okay. So the slide I want to pull up is the number of hours that have been donated and validated per language. So when we think about what makes a useful data set, there's a lot of different dimensions. There's number of hours is kind of one dimension of what's a good data set. Bigger data sets are usually better, not always the case. But bigger data sets are better. More diverse data sets are better. There's been a huge problem in not just the past, it's still a huge problem that data sets for training these speech algorithms can be biased towards men. And we found this with a lot of different commercial products. There's tons of publications out there. If you Google around, you will not have a hard time finding this. So gender diversity is very important. Accent diversity is very important. This is also something that's, there's research on it, but also it's just intuitive, especially if you speak English and you have tried using any voice technologies. You can discover very quickly, depending on your accent, how well the technology works for, there's some famous examples when the voice assistants were first getting out into the mainstream, that Scottish English speakers were just not finding them usable at all. If you speak English as a second language, it can be very difficult too. That's because the data set which was used to train the machine learning algorithms didn't have enough accent diversity in it. And another point of a dimension of what makes a data set good is number of speakers. So I mentioned earlier on that there's speech to text is one part of the pipeline for speech technology. Usually there's speech to text, text understanding, then there's some kind of speech generation, speech synthesis. I said that if you're a single motivated developer, you might be able to go and collect all the data you need, except for the speech to text bit. That's because speaker diversity is really important if you want a technology that will work for more people than just you. I could go right now and collect the data of me speaking, me walking around, just recording my voice for an hour. And then I could train a speech recognition algorithm on it. And it might be really good for me. But if I give that to somebody else, they're not going to be able to use it at all, even if they're from the same town, if they have the same accent. It's not going to work. So what is really important is the number of different speakers. And that's something that I want to bring up here, because these data sets are different for a lot of reasons. When I compare the underrepresented languages like Kinyarwanda, Catalan, and Kabyle that have been able to activate the community, something that they have to work extra hard for is getting more speaker diversity, number of speakers, because they can get hours, they can find people who are really, really motivated. And that's important. You can get 10 hours of audio from one person in a few months, and that's amazing work. But what's also very important is getting more people in, getting more voices into the data set, because that way the technology that you build on the data set scales to new people. So that's something that's really important to keep in mind when you're working with like Dutch and Frisian. It's great to donate lots of data. Don't donate less, but make sure that you're finding people, motivating them to donate, because just basically 10 audio clips from one person are not as useful as 5 clips from 2 people each, right? So there's more diversity is good there. Yeah, that's what I think comes to mind when I think about number of speakers in these data sets.
That's amazing. Yeah, thanks, Josh.
Yeah.
Another question, do you have any advice for quality recordings?
So, okay, I'm going to interpret that as the quality of the recording, like the background noise and kind of what makes a good audio recording. So this might be counterintuitive, but I think I mentioned it earlier. Real background noise is important. When we're all on these Zoom calls, we think it's really important to have good quality audio, to have quiet, to have all your fans turned off, to not have people talking in the background. But when it comes to creating speech data sets, especially with Common Voice, it's important to get lots of different background noises in the audio. And that's simply because if you collect a very kind of quiet or clean data set, that data set is useful for training machine learning models, which in turn perform best on quiet, clean data. So this is a huge problem. Okay, when I talked about traditional speech corpora, the one in the middle is called LibreSpeech. LibreSpeech is a project that took audiobooks from English, and recently other researchers have expanded it to more languages. But let's say they're audiobooks. They're open domain audiobooks. Researchers took those and they cut them up into audio clips that are long enough to be useful for the speech recognition technology. So the research community has been able to get lots and lots of data from audiobooks. But the problem is it's too clean. If you train a speech recognition model on this data, when you deploy that model and it goes into somebody's house, it goes into somebody's car, it goes into a restaurant, as soon as you get background noise, the performance just degrades significantly, because the model has never heard what a running car engine sounds like, and it's never been able to learn to ignore the running car engine. So the more noise you get in the background, as long as what you're saying is audible, that's perfect, because the model then learns to ignore what's not human speech and what is human speech. And then once it understands what is human speech, then it can kind of decode what are the actual words. Okay, so that's what I want to say about the quality of the audio when it comes to background noise. Also, when it comes to speaking, what makes a good audio clip for Common Voice in particular is making sure that you read every word on the screen. It's really as simple as that. Reading every word on the screen and not maybe trying too hard to pronounce it as it maybe your teachers said it should be pronounced, but how people actually pronounce it, how you would pronounce it. That's important because these systems, at the end of the day, we want to collect data so we can train speech learning, algorithms that we can use for real life applications. And in real life applications, people talk like normal people. They don't talk like they're reading a sentence very carefully, making sure they pronounce every single letter as their teacher in middle school said. They're speaking as they're speaking, if that makes sense. So natural speech and natural backgrounds are what are really important.
That's incredibly encouraging that I don't have to set up a studio and take elocution lessons.
No, you don't want to do that.
So you do have a bunch of questions coming in now, actually, so I'm going to keep going.
Okay.
Does a diverse data package also consist of high and low tones with mumps without a mouth cap, or if you are calling while standing on the wind?
Okay. High and low tones. So I don't know enough about Dutch and Frisian to know if tone, how important that is for the languages. So high and low tones, if I was thinking about this for a language like English, I would think people with deep voices, people with high pitched voices. That's really important. That goes into the same category of kind of speaker diversity. We want more speaker diversity. We want more voices. If we have, people who are 7 feet tall and little kids, they're going to have different tones of voice in terms of pitch, which is called fundamental frequency, is how I'm interpreting this. That's very important. There's another way you could think about tone, which is kind of what I would call sentence level prosody, which is just saying the same sentence different ways. If in English I say, I don't know, the dog chased the cat, I could say the dog chased the cat as opposed to some other animal, or I could say the dog chased the cat as opposed to doing some other action, and I could say the dog chased the cat, which means the dog wasn't chasing some other animal. All of those kinds of intonation, which are sentence level, and they do affect the meaning in certain languages. Getting that kind of diversity is also important. That being said, if you see a sentence on the screen, just read it once. With a certain intonation, just choose one. Don't repeat the sentence multiple times. So that kind of variety is also important. There was a couple other things in there, Abby.
Yeah, I think the last part of the sentence says with mumps without a mouth cap, or if you are calling while standing on the wind.
Okay. I'm guessing maybe a mouth cap is like a face mask for
I'm not
since
sure.
wearing. Well, that's actually something that's really relevant too, right? Now we have the pandemic. People are wearing masks and they're talking on the phone using masks. That does in some ways change the audio quality of the voice. So that is also good audio to get. It adds variety, it adds diversity into the data set, so that's good. Talking into the wind is a great example of where modern speech technologies fail. I'm going to use the example of calling my bank again because I've had this experience I feel like I'm a little more, I think about it maybe a little more. So I remember this, I was on a call with my bank and it was a really windy street and I had to go into a side street just so that the voice bot would understand me. And this is American English, which is most of the models are, there's more data around for American English, unfortunately. So yeah, all that kind of background noise is really important, and diversity in speakers is very important.
Thanks, Josh. So next question, do you take into account that language that is read from preset samples could be a lot cleaner and sometimes even hyper-correct as compared to spontaneous language usage and pronunciation?
Yes, so this is a great question. This is true. It's read language, read speech is different from spontaneous speech. There's tons of linguistic research that shows this is true and shows how it's true. And so it is an aspect of Common Voice that some people might look at and say it's not as good as it could be because it's not spontaneous speech, and what you really should do is get spontaneous speech and then transcribe it. So I think this is kind of a pros and cons. The project Common Voice would not be able to scale to new languages in such a fluid way, and it would not be able to grow to become so massive as it is now if it weren't set up the way it is. Spontaneous speech is just, you can't make, it's hard to motivate people for a community-based project that involves transcribing spontaneous speech. So that's all kind of about why Common Voice doesn't have spontaneous speech. But yes, it's true that spontaneous speech is different from read speech. And which is why I'm encouraging people, when you are reading speech, try to read it in a way that sounds more spontaneous. That might be kind of difficult to do, but for example, if it's a short sentence, if you can memorize it and then just say it back instead of reading it word for word, that's one way to get around that problem. But yeah, it is a problem. I don't think it's as big of a problem as it might come across. I think that it's still, well, I know that it's still possible to make commercial products for spontaneous speech using this data. People have already done it. There are products out there. There are models that have been trained. So yes, so at the end of the day, if you can read in a more natural, conversational, spontaneous way, that's better. But it's a good point.
Nice. And we'll do one more question. Besides regional accent, one particular challenge in voice recognition for elderly and children, perhaps Contribute-a-thons could target diverse profiles.
Yeah, it's very true, especially for children. I think more so than the elderly, because the acoustics of how kids speak, the kind of the frequency ranges, they're higher pitched, and it makes it more difficult. That being said, if you can identify groups in the population that are experiencing worse speech technology performance, if you can identify these groups, because it might be for one language, for one accent, one dialect, it's the models are really not working for, women between 40 and 60, or it might be not working really for men who are over 75 or younger than 15. If you can identify the groups and then start a kind of campaign to try to find more of those voices, that's really important. Generally speaking, children and the elderly are the ones that are having the hardest time with the technologies, and it's because of a lack of representation in the data. But before you go collecting a bunch of kids' speech, make sure you read and understand the terms and conditions, so that you're doing this ethically. You don't want to be convincing people to donate to something that they don't understand. So make sure that you understand that.
So that's a great point to end on. Thank you so much, Josh. And it's been great to see people are even commenting on each other's questions, which is really exciting to see this kind of engagement.
Yeah, this is a really exciting project. I'm very, very excited to see what this week brings.
Yeah, me too. So yeah, huge thanks to our speakers. I do want to share a little bit more about our partner institutions right now. So both of our partners actually have new voice or speech tech programs coming up. So first, the Amsterdam University of Applied Sciences has a new minor conversational interface, which is aimed at non-technical students who want to design and create amazing, innovative, and inclusive applications for speech and chat. So this minor starts in semester 2 for the 2021 to 2022 academic year. And to read more about that, you can go to conversational.amsterdam. Sorry, I don't have a slide for this part. And then the second school that we're partnering with, University of Groningen, Campus Friesland, they have a new Masters of Science in Voice Technology. So this new master's program is a one-year interdisciplinary master's program dedicated to researching and developing speech recognition and voice synthesis software in a highly collaborative, interactive environment. To learn more, you can go to rug.nl/cf/voice technology. And you'll be hearing more about this in the closing event, where Matt will be emceeing and hosting a panel. So just as a reminder, over the next week, we are challenging any Dutch and Frisian speakers to use Common Voice to record and validate as many hours as possible of your language. So I'm just going to share questions. I know Josh already shared lovely animated GIFs telling you how to do this, but if you speak Dutch, please go to the commonvoice.mozilla.org/NL URL, and that's where you can both record and validate speech. And if you speak Frisian, go to commonvoice.mozilla.org/FY-NL. And while you're contributing, I'd encourage you to actually create an account. So I've highlighted that button there in yellow. That way, at the end of the week, you might be eligible to claim a prize. So we do have some limited swag available. You might be asked to pick it up on your campus, or you might be able to mail it to you. But do create an account. That way, you'll be eligible to claim something. And if you want to look at the stats over the week, you can go to this URL, mzl.la/CV challenge. That was our hashtag for today. And you can see all the contributions in both Dutch and Frisian, sort of compared against one another. It's a fun challenge to see who wins. And just as a reminder, we are using the data that you've collected this week at MozFest. So MozFest is happening March 8th to 19th, both mostly virtual, but Amsterdam is our home base. And early bird tickets are available now. So you can grab a ticket at mozillafestival.org. And hopefully you can join us at the hackathon, where we'll actually build something with all of this great data. So I think that's all I have for today. Huge thanks again to all our speakers. It's really such an honor to hear from both you, Josh, and Nanda, who had to leave. And the challenge begins as soon as this call ends. So I'm hoping that as soon as you close your YouTube browser, you'll go straight to Common Voice and start recording. But we'll see you at the same time next week for our closing event, where we'll have a great panel and we'll hear more about the hackathon that's happening at MozFest. All right, thanks everyone.
Bye.